In this episode, we're going to treat supply chain risk in OT as a real, everyday part of security rather than a mysterious threat that only matters during major scandals. When you're new to cybersecurity, it's easy to picture attacks as something that happens directly to your network, like someone trying to break in through a password prompt or a phishing email. Supply chain risk is different because the problem can arrive already packaged inside the things you buy, install, trust, and depend on, including hardware, software, firmware, updates, and services. In operational technology, that matters even more because systems can run for years, upgrades happen on careful schedules, and vendor relationships are woven into maintenance and support. This means a single dependency can quietly become a long-term pathway for risk, not because anyone is careless, but because modern industrial environments are built from many interconnected parts. The goal of this lesson is to help you recognize where those dependencies exist, how they create exposure, and how you can manage them in a realistic way that supports safe operations. When you understand supply chain risk, you stop thinking only about protecting what you own and start thinking about protecting what you rely on. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to begin is to define what supply chain risk means in OT without overcomplicating it. Supply chain risk is the possibility that something you depend on introduces weaknesses or malicious behavior into your environment, either accidentally through poor quality and insecure design, or intentionally through tampering, compromise, or hidden functionality. In OT, the supply chain includes physical devices like controllers, sensors, switches, and engineering workstations, as well as software components like operating systems, management tools, drivers, and specialized applications. It also includes firmware, which is the low-level code that runs inside devices and can have powerful control over behavior. Beyond that, the supply chain includes vendor services, support channels, update delivery mechanisms, and even the people who install and integrate systems. Beginners often assume that if a product is from a reputable vendor, it must be safe, but reputation is not a guarantee because vendors can make mistakes, vendors can be targeted, and the complexity of modern development makes hidden issues possible. Supply chain risk is not a claim that vendors are untrustworthy by default. It is a recognition that dependencies create shared risk. Once you accept that, you can manage it calmly instead of being surprised by it. Hardware supply chain risk is often misunderstood because people assume hardware is inert, like a box that only does what you tell it to do. In reality, hardware can include embedded systems, programmable components, and management interfaces that affect how the device operates and how it can be accessed. Hardware risk can come from counterfeit parts, unauthorized substitutions, or tampering during manufacturing, shipping, or storage. It can also come from design decisions that prioritize convenience over security, such as default credentials, exposed debug interfaces, or insecure remote management features. In OT, hardware is especially important because it often sits close to physical processes, and failures or manipulation can have direct operational impact. Beginners sometimes focus on whether the device is connected to the internet, but hardware risk can exist even in isolated environments if a device is compromised before it arrives. Another OT-specific issue is long life cycle, because a device purchased years ago may still be running, and its hardware limitations can prevent modern protections from being added later. When you assess hardware supply chain risk, you are not only asking whether the device is safe today, but whether it will remain supportable and secure over its operational life. That long view is part of what makes OT supply chain thinking so important. Software supply chain risk can feel more familiar because many people have heard about software vulnerabilities, but in OT the context changes how those vulnerabilities matter. OT software often includes specialized applications for control, monitoring, configuration, and maintenance, and those applications can have deep privileges because they must interact with devices and processes. If a software component is compromised, it can become a powerful pathway for unauthorized changes or disruption. Software supply chain risk includes the code that vendors write, the libraries they use, the build systems they depend on, and the distribution channels that deliver updates. It also includes third-party components embedded inside larger products, which can be invisible to the customer but still part of the risk. Beginners sometimes assume that patching fixes everything, but in OT, patching may be delayed by maintenance windows, vendor qualification requirements, or operational constraints, which means a software weakness can remain in place for a long time. Another challenge is that OT software may run on older platforms that are harder to secure, making the impact of supply chain issues larger. Assessing software supply chain risk is therefore about understanding what software you rely on, what privileges it has, how it is updated, and how quickly issues can realistically be addressed. The more you know about these factors, the more accurately you can judge exposure. Firmware deserves special attention because it sits between hardware and software and is often harder to see and harder to validate. Firmware can control device behavior at a low level, and it can persist even when other software is reinstalled. In OT, firmware updates might be infrequent, vendor-controlled, or bundled into larger upgrade packages, which can make it difficult to keep firmware current and verified. Firmware also tends to be less transparent, meaning customers have less visibility into what it contains and fewer tools to inspect it. Beginners might assume firmware is static and safe, but firmware can have vulnerabilities like any other code, and it can also include management functions that expose a device to remote access or configuration changes. In a supply chain context, firmware risk includes the possibility of compromised update packages, unauthorized firmware modifications, or even misconfigured firmware settings that weaken security. The practical challenge is that OT teams may not have a clean inventory of firmware versions across devices, which makes risk assessment harder. A realistic approach starts by improving visibility, such as tracking which device types exist, which firmware families they use, and which versions are deployed in critical zones. When you can see firmware as part of your dependency map, you can manage it rather than leaving it as a blind spot. Vendor dependencies in OT extend beyond products and into relationships, and this is where supply chain risk becomes a human and process issue as much as a technical one. Many OT environments depend on vendors and integrators for maintenance, troubleshooting, upgrades, and specialized expertise. That dependency often requires remote access, on-site access, and shared workflows, which can create exposure if not managed carefully. A vendor might have legitimate reasons to access systems, but their accounts, devices, and support channels can be targeted by attackers who know that vendors provide a pathway into many customer environments. Integrators can also introduce risk through configuration choices, reused templates, or undocumented changes, especially if they are under time pressure. Beginners sometimes treat vendors as external to the security model, but in OT, vendors are often part of the operational model, which means they must be part of the risk model as well. This does not mean you treat vendors as adversaries. It means you define expectations, controls, and accountability for how vendor work is performed. Good supply chain risk management includes clear remote access rules, clear change documentation requirements, and clear processes for responding when a vendor reports a vulnerability. When relationships are structured, dependencies become safer. One of the most practical supply chain risk questions is how updates and patches flow into the OT environment. The update pathway itself is a vector because if update packages are compromised or delivered through insecure channels, the update mechanism becomes a distribution system for harm. In OT, updates may arrive through vendor portals, integrator-delivered media, centralized enterprise systems, or manual transfers, and each method has different exposure. Beginners might assume updates are always beneficial, but an untested update can cause operational instability, while a delayed update can leave known weaknesses unaddressed. That tension means OT update processes often involve validation, scheduling, and stage deployment, which is good for safety but can slow risk reduction. Assessing supply chain risk includes evaluating whether update packages are verified, whether sources are trusted, whether the update process is documented, and whether emergency updates can be handled safely when needed. It also includes asking whether updates are tracked across sites so you know which systems have received which fixes. The goal is to make the update pipeline controlled and visible, not hurried or ad hoc. When the update pipeline is disciplined, it reduces both accidental disruptions and supply chain exposure. Supply chain risk also includes the risk of hidden dependencies, where a product includes components you did not explicitly choose. A control system application might embed a database engine, a web server, or a remote management feature that creates unexpected exposure. A device might include a management interface that is enabled by default or a service that listens for connections even when you do not intend to use it. Beginners often think they are buying one thing, but they are often buying a bundle of components with different security properties. This is where asset inventory and component awareness become important, because you cannot assess risk if you do not know what is present. In OT, component awareness can be challenging because documentation may be incomplete and because vendors may not provide full transparency. Still, you can improve the situation by tracking product models, firmware families, known embedded services, and the network behaviors you observe. You can also assess whether the product requires unnecessary connectivity or uses insecure defaults that increase exposure. The key is to treat every product as a set of dependencies with a security profile, not as a single box with a single label. When you shift your mindset this way, supply chain risk becomes something you can analyze rather than something you fear. A central part of assessing supply chain risk is evaluating how much you can trust and verify, because trust without verification is fragile. In practice, verification can include confirming that devices are sourced through approved channels, that firmware and software versions match expected baselines, and that updates are obtained and applied through controlled processes. Verification can also include monitoring for unusual behavior that could indicate a compromised component, such as unexpected outbound connections, new services appearing, or configuration changes that do not match planned work. Beginners might think verification requires deep technical inspection of code, but much of the value comes from simpler checks that increase confidence and reduce surprises. For example, if you know exactly which versions are deployed in a critical zone and you have a stable baseline of network behavior, then deviations become meaningful signals. Verification also involves governance, such as requiring vendors to communicate vulnerabilities, requiring integrators to document changes, and requiring contracts to include security expectations. These are not just legal details. They shape operational reality by defining what you can demand and what you can measure. When trust is supported by verification, supply chain risk becomes manageable and less dependent on hope. It is also important to understand how supply chain risk interacts with asset criticality, because not every dependency deserves the same level of scrutiny. A component that supports a safety-critical process should receive more careful sourcing, stronger update controls, and more rigorous validation than a component that supports a low-impact monitoring function. This is not about ignoring low-impact systems. It is about prioritizing effort where consequences are highest. In OT, high criticality systems often have specialized vendors and long replacement cycles, which increases dependence and therefore increases supply chain importance. That means your risk assessment should connect dependency analysis to criticality tiers so you can focus on the combinations that matter most. Beginners sometimes spread attention evenly across everything and end up overwhelmed, but supply chain risk management works best when it is focused and systematic. A practical approach might involve identifying the most critical vendor relationships, the most critical product families, and the most critical update pipelines, then assessing how each one could introduce harm. You then decide which controls are necessary, which are desirable, and which are unrealistic given constraints. When criticality guides scrutiny, the program stays sustainable. Supply chain risk in OT is also influenced by procurement and lifecycle management, which can feel far from cybersecurity but actually drives it. Choices made during procurement determine what security features are available, what support commitments exist, and how quickly vulnerabilities can be addressed. If you buy equipment without clear security documentation, without a predictable patch process, or without support for secure remote access models, you inherit risk that may last for years. Lifecycle management matters because when support ends, vulnerabilities may remain unpatched and replacement may be expensive or slow. Beginners sometimes assume security is something you bolt on after purchase, but in OT, many security outcomes are set by design choices and vendor capabilities. Assessing supply chain risk, therefore, includes reviewing how products are selected, how vendors are evaluated, and how end-of-life decisions are made. It also includes planning for transition, because replacing a critical system is not a simple swap. It can require revalidation, retraining, and coordination with operations and safety. When you incorporate supply chain thinking into lifecycle planning, you reduce the chance of being trapped by unsupported components. That is a quiet but powerful form of risk reduction. Finally, assessing supply chain risk is about building a realistic posture that acknowledges dependency while reducing exposure and increasing resilience. You cannot eliminate vendors, software components, or hardware supply chains in modern OT, but you can shape how those dependencies interact with your environment. You can reduce unnecessary connectivity, enforce controlled update pathways, require documented change practices from partners, and improve visibility into what is deployed where. You can also build resilience by ensuring you can restore systems to known good states, because if a supply chain issue does slip through, recovery capability limits consequence. For beginners, the main lesson is that supply chain risk is not a separate category of fear. It is a lens that helps you see where trust enters your environment and where that trust could fail. When you map dependencies, define expectations, and validate what you can, you turn supply chain risk into a series of manageable decisions. Those decisions should always align with OT realities, protecting safety and uptime while steadily reducing the chance that a hidden dependency becomes a major incident. That is what it means to assess supply chain risk in OT, and it is one of the most practical ways to strengthen security without creating chaos.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.